So let's talk about what you need to know in order to succeed, in my opinion, in calculus. Now, I've completed obviously high school calculus, I've completed university calculus, and some of the things that's quite apparent in calculus would be the following. So first, you need to be familiar with perfect cubes or perfect squares, right? Meaning that to solve perfect squares, we can use, this is going to be a whole bunch of things, again, in my opinion, that I think you need to know in order to sort of succeed in calculus, because in calculus you need a strong understanding of algebra, and through logical reasoning you can actually find most of the answers by just following some techniques, right? So in this case, we're just going to break this up into x minus 3, x plus 3. Let's look at the next one. What if we have x cubed minus 27? Well, in this case, I'm going to say difference of perfect cubes. I can rewrite this as a minus b, a squared plus 2, a squared plus ab plus b squared. So in this case, I'm going to simply take one of these x's, and we know the cube root of 27 would be 3. Why is that? Since 3 times 3 times 3 is equal to 27. And we can argue that, well, this is negative, negative, negative. So these two give me positive and negative. So then I can say, well, x minus 3. And you can multiply this into the parentheses to sort of figure out or to see that this a square minus b square multiply a square plus ab plus 2b works out. You can test it by yourself. Anyway, so that's going to give me 3x, since I'm going to take a multiply b, which is 3 multiply x, and then plus 9. Okay, so these things are very important for when it comes to concepts like limit. So let's say the limit as x approaches 2, and we're given the equation x squared minus 4 over x minus 2. Well, if we simply just plug in the 2, we'll get some undefined function. And what if we want to find the limit to this function? Well, now we need to know the difference of cubes. We need to know this in order to solve. What this means is I can just say simply x minus 2, x plus 2 over x minus 2. Simplify, simplify, direct substitute, 2x plus 2. Now, I would argue that you need to understand the following concept as well. The f of 2, input versus output. This is going to be a very important fundamental, especially when you start with derivatives, where you might have the f of b minus the f of a over b minus a. So rate of change concepts, right? So understanding what input versus output is fundamentally very important. So the word you might be familiarized with is evaluate. So evaluate the f of 2. So let's say we're given some function x plus 2. We can evaluate this as 2 plus 2. Therefore, it's 4. Now this concept relates all the way to a derivative concept. Okay. What are some exponential rules, however? So here's 3 different things you need to know before starting calculus. What about some exponential rules? Some exponential rules, that's very important. Well, in this case, let's say you have x squared divided by x. The answer would be x. How we can rewrite this is x squared minus 1, since dividing is just subtracting the exponents. What about another rule? Another rule that's very important is 0 to the power of x to the power of 0. Well, this gives me anything to the power of 0 is 1. Now, this is very, very important. especially when you try to find derivatives of, let's say, some type of constant. You need to know this property, or if you find the antiderivative of this constant. Another important fundamental or exponential rule would definitely be what happens in these type of situations where you multiply exponents. So when you multiply exponents or variables with exponents, you can simply just add the variables. Okay, so that gives me 6. And then we can actually just follow all the exponential rules. So 2 to the power 4. In this case, we multiply our exponents. So it's going to be x to the 8. Okay, let's look at another one. Factorizing of quadratics. Now, this would also be considered some important fundamental in a case where, let's say, you're asked to find a limit where x approaches some value, right? And in this case, it's important to follow or to know how to factorize these quadratics. Well, there's multiple methods you can do that. The one I like using is you input your c value over here, your b value in there. So let's do this. How do we find? So it's going to be ax squared plus bx plus c. So in this case, we have c would be 16. We have 8. What multiply? What can give me 16? Well, in this case, it's just simply 4 and 4. So then I can say 4 plus 4 is equal to 8. So I can rewrite this as x plus 4, or simply I can rewrite this as x plus 4 squared. Another few concepts that I think are very important is you need to know some basic functions. Okay, the two most basic functions you need to know is definitely y is equal to mx plus c or b. It can be c, b, or k actually, or we can have y is equal to x squared. So how these functions look is, let's say we're given some f of x is equal to 2x plus 4. We know we start at our y-intercept. We go 2 up, 1 right. So this is how we can graph it. Now, why this is so important is that sometimes you have to measure the change over time, especially when it comes to like speed or temperature. You need to know how to measure the change over time. And for that, we are using slopes. Now, I'll get to slopes in a second. Slopes are very important, or gradients. For the following function, x squared, very simple. It's just a parabola that opens up to the top. Okay, it opens up to the top. So we can see that the domain of this parabola is x is an element of all real numbers. However, the range just has to be, since we're at the origin of the graph, which means 0 all the way up until infinity. So we can therefore say the range is 0 up until positive infinity. So now let's get to another one. So another one is definitely slopes. Slopes is a very, very important part in calculus, especially derivatives. Slopes. So what is a slope? Well, a slope is just a change in the direction of the line. So let's say we have some function where you have this. We can indicate, well, this function is increasing, so the slope must be positive. Over here, we have some maximum point. The slope is going downwards, so therefore the slope is negative. And when the function goes up again, well, at this point, which is our minimum, we have our slope, which is positive again. So we have a change in the slope, negative, positive, or positive, negative, positive. So how do we calculate the slope? Well, the slope is just given to as delta y over delta x. And to solve these type of equations, all you need is 2 sets of coordinates. Okay, so slopes are important, especially when it comes to concepts in limits where you might have to find some line of tangent or where you have to calculate some change over some time by looking at the derivatives, deriving a function, or line of secant, line of tangent. Derivatives are just important in general. Okay, so we know that delta y over delta x means the change in y over the change in x. If I can put this into a function, let's see why we start with y2. Well, let's say I start at point 1. Let's say I start over here, point 1. Well, let's call this point A. And I finish at point B. I'm going to take these coordinates and subtract them from these coordinates in this format. Okay, so we calculate the slope. So we can measure the change in y over the change in x. Okay, so here we have delta y and here we have delta x. And that's pretty much how you solve these type of equations. One of the exponential rules I actually forgot, which is definitely very, very important when it comes to deriving functions, would be a square root. Right? So a square root, we have this 1, 2. So we can rewrite this actually as square or a half. Square x raised to the 1/2. Okay? So let's do another example. An example would be, let's say we have temperature raised to the 4th power. And this is in some square root raised to the 7th. We can rewrite this as t raised to the 4/7. This is very important for when it comes to topics like derivatives, where you might be asked to find the derivative of the square root of x. And in this case, you have to sort of do something that looks like this. I think I made a video on derivatives already, where you have x raised to the 1/2 minus 1 and bring this 1/2 forward. Okay, so very important topics. Now, let me just quickly have a think. If this is all I would recommend you familiarize yourself with. Just in general, strong algebraic skills is also quite important. So for instance, let's say we're given the function 2x minus x over x. In this case, we need to familiarize ourselves, and let's say you ask to find the derivative of this this function. Well, here we should notice that we can do something first, right? So what would that be? Well, I see that both these terms contain an x, so I can factorize. So factorizing is also a very, very important part in calculus, factorizing, okay? And simplifying of answers, ooh, very important. Okay, maybe do a little example quick, where we have this one, 2x plus 4, 3x plus 7. Okay, we're going to do this example as well, using the FOIL method. Okay, so in this case, I can factorize. Well, I can factorize with an x. I'm then left with x minus 1 over x. I can cancel out these terms, so I'm left with an x minus 1. Now I can simply just derive this x minus 1. Very easy stuff. And let's go over to our final part that I would recommend you know before starting the journey in calculus. I mean, there's obviously a lot more like log rules, but in derivatives, usually the log rules are explained to you anyway. Oh, all right. I almost forgot about two more things. Okay, so here we have the FOIL method, which just means first, outers, inners, and lasts. So firstly, you're going to take this term and multiply it with everything in the parentheses. And then secondly, you'll take this term and multiply it with everything in the parentheses. Very simple. So we're going to have 6x squared plus 14x plus 12x plus 7 times 4 is 28. We have 6x squared plus 26x plus 28. Now we can obviously simplify this one. We can simplify this one with a 2. So let's do that. Let's take out a 2 out of the entire equation. So if I divide this by 2, divide this by 2, divide this by 2, I get 3x squared plus 13x plus 14. So this would be my final answer. Okay, two more very important notes, and these are calculus notes. In integration, always remember plus c. Okay, always remember plus c. And just remember the following statement: e to the x is equal to e to the x. Trust me. Remember this statement: e to the x. Your teacher will later do proofs with you. Obviously, if it's my students, I will do a proof with them. But e to the x is equal to e to the x. And your final integration, do not forget plus c. Trust me.